All right, we're going to be talking about rational exponents today, and let's talk about what those are. Rational exponents are exponents that are fractions. So if I'm looking here, all exponent laws are going to still apply to non-integer or rational exponents, these fractions. A rational exponent can be rewritten as a radical, that's that square root sign there, but it could be any root is the n value, which is the denominator of the fractional exponent, and the numerator here becomes the exponent, which is the number under the radicand. There's a couple things you want to know is I apply this bow tie, which means bottom out, top in. So the bottom of the fraction comes out to be the root. The top comes in to be the exponent. I do also want to make sure that you recognize if I see a radical without a number here, that means that it is a 2 for the root. I also don't see an exponent. That means the exponent is a 1. So this square root of x can be rewritten as a rational exponent as x to the 1/2, where x could be any number here. So let's look at some examples. So the first thing I'm going to look at here is 25 to the 1/2. If I rewrite that as a radical, right, that bottom out, top in, means I really have the square root of 25 to the first power times, well, we don't really write either of those, so this one I'm going to write just as the square root of 25. Well, the square root of 25 is 5 times the square root of 25, which is 5. That gives me 25. So that's what's happening there if I'm converting between the two and how I would simplify. So let's look at also the nth root of a. So the nth root means any number here as the root of a being the number inside the radical. There's a couple cases you want to look for. N must be bigger than 1, and a must be a real number. And we haven't worked with imaginary numbers, so we really should only be seeing real numbers here. But n can be odd or even. If n is odd, there's only one real root answer. There's only going to be one number you get as your answer. But if n is even, a few things can happen. If a is bigger than 0, there's going to be 2 real roots where whenever I plug in my calculator, I'm going to make sure I put a plus or minus whatever that answer is. When n is even, but a is equal to 0, there's only one real nth root, and that answer is just 0. If n is even and a is less than 0, there's going to be no real nth roots. Okay, so let's look here. We're going to rewrite each of these into either a radical or a rational exponent form. So here I'm starting with a radical. I don't see a root. I'm going to make it a 2. I also don't see an exponent, which means it's a 1. So I'm going to rewrite this. 10 is the base to the 1/2. The root is the bottom, the exponent is the top. So I get 10 to the 1/2 is me rewriting this radical as a rational exponent. Same thing's going to happen here. I see that 34 is my base. I see my root, which is the bottom, but I'm missing my exponent. So my exponent's a 1, so it becomes 34 to the 1/5. Looking here, I'm going the other way. So I'm going to do that bow tie, bottom, out, top, in. So 15 is the number inside my radical. The 3 is my root. The 1 is my exponent. Now we don't write that 1, so I'm going to rewrite my final answer as the third root of 15, or the cube root of 15. This next one you want to be careful. I do see that I have a negative number. So when I make my radical, I want to make sure I put a -4 in, just like I have here, in parentheses. Bottom out, top in. So bottom out, top in. Now let's work with those nth roots. That might have been the confusing part from the top. So basically what I want to do is I'm going to make a radical, put the a value inside, and the n value is my root. Now n is even, so when I plug this in my calculator, I know that I should get a plus or minus answer. Okay, so I'm going to have a plus or minus because n is even. I'm going to plug in the square root. So I can do the blue button and then this button right here to get my square root symbol, type in 36, and I get 6. Now here's why I need a plus or a minus, because if I go backwards from a square root, that means I'm squaring my number. So 6 squared is 36. -6 squared is also 36 because a negative times a negative is a positive. So my final answer for the nth root is going to be a plus or minus 6. Okay. Number 6, same thing. A goes inside the radical, n is the root. This is even, which means I'm going to have a plus or a minus here. Now, how do I put a fourth root in? you're going to hit that math button. And I'm gonna look here. This option 5 lets me put any number I want as my root. So I'm gonna do option 5. I'm gonna put a 4 here for the root and 81 inside, and I get 3. So my answer here is plus or minus 3. Number 7, a goes inside my radical, n is the root. Now this is odd, which means I'm gonna have just one answer, so whatever comes out of my calculator is my answer. I'm gonna go back to that math button. I could use option 5, but they do have a special cube root button here, so I'm just gonna hit 4 and type in 1000, and I get 10. Again, it's odd, so only one answer. Number 8, also an odd n value. So let's see, a goes inside my radical, 9 is my root. So I'm gonna go ahead and we're going to hit that math button, go to option 5, make 9 my root and negative 512 the a value inside, and I get negative 2, and because n is odd, that is my only answer there. So that negative 2 is my only answer. All right, we're gonna evaluate each expression. I'm just gonna plug these in my calculator. So I need the 4th root of 256. So math, option 5, 4th root of 256, and that's going to give me 4. The 3rd root of negative 216, so the 3rd root of negative 216, that is negative 6. All right, these ones have rational exponents, but I can still find those very similarly. I'm gonna plug them in my calculator. So I'm going to put that, notice the parentheses around negative 27, and I'm gonna go up, that little up arrow button gets me to the exponent, and I can just type in 2 divided by 3, that's what a fraction is, and hit enter, I get 9. All right, last one here, again, put parentheses around that negative number. And I'm gonna hit that little up arrow again right here, and I'm gonna type in 3 divided by 2. Ooh, I get an error that says non-real answers. Well, that is what I'm gonna put. I'm gonna put non-real answer. That's what I get. All right, let's look at number 13 and 14. We got some word problems here. I'm gonna find the length of the side A, the side of a cube if the volume is 216 feet cubed. Well, the volume formula is s squared, where s represents the sides. Well, if I know the volume is 216, now this feet cubed, that's just the label. I don't do anything with that as far as plugging that 3 anywhere. Equals s cubed. Now, if I want to undo something that's being raised to the 3rd power, you're going to take the 3rd root. So I'm gonna take the 3rd root of 216. So when I take the 3rd root of 216, which kind of already did here, I'm gonna hit math, I'm gonna go to option 4, I've got 216, that's going to give me 6. So I get 6 equals s, so the length of the side is 6 feet. Okay, so I get 6 feet. Now it's 1 dimension, so it's just feet as my label. All right, last one here, we're gonna look at the area of a square patio is 64 to the 3rd. Now this is what the area equals, like this is my A. Now a square, the area formula, A equals s squared. So I'm going to plug the area, which is 64 to the 3rd, in for A, all of that. I need to find s, so I've got s squared, s being one side of my patio. So I need to take the square root to undo the square root, something being squared. So I get s equals, so I'm gonna plug that in my calculator, just how I see it. So I'm going to take the square root, and I'm gonna plug in 64 to the 3rd, hit enter. I get 512. So 512 is the length of my side. Now that seems really big, right? Because 512 is bigger than 64, but that's not just 64. It's 64 to the 3rd, which is this. It's a really big number, right? So that is the side length here.